I'm going to be doing problem number 55 on page 590. The problem reads, an electric car is designed to run off a bank of 12-volt batteries with a total energy storage of 2 times 10 to the 7th joules. If the electric motor draws 8 kilowatts, what is the current delivered to the motor? B, if the electric motor draws 8 kilowatts as the car moves at a steady speed of 20 meters per second, how far will the car travel before it is out of juice? So, for A, all we need to do is we know that we have 8 kilowatts, and I personally like to change things to the base units, so that's 8,000 watts. And we know that watts is equal to current times voltage. So we know that the voltage is 12 volts, and we know that the current, or we were trying to find the current. So all we need to do is bring the volts over and find watts over volts equal to current. Plug everything in and we get 8,000 watts over 12 volts equals I, which ends up equaling 666.7 amps. So that's part A. Part B asks, if the electric motor draws 8 kilowatts as the car moves at a steady speed of 20 meters per second, how far will the car travel before it's out of juice? Again, I like to convert everything to its base units, so 8,000 watts. We know that, let's see, so a joule, or a watt, is equal to a joule over a second. So, since we're trying to find seconds, if we switch these two around, a little bit of algebra, we get seconds is equal to joules over watts. Now we know how many joules. It's equal to 2 times 10 to the 7th joules, and there's our watts, so seconds is equal to 2 times 10 to the 7th joules, or over 8,000 watts. And there we get how many seconds it'll run for, and that ends up equaling 2,500 seconds. So now we know how many seconds it runs for, and we know that it's moving at 20 meters per second, and a second times a meter per second will cancel out to get a meter. So 2,500 seconds times 20 meters per second. Seconds cancel out, and you get 50,000 meters, or 50 kilometers. And that's the problem.